Okay, good morning and welcome back, students. So we are in the final episode of our lesson. The title of our lesson is Simple Machines, and today we will be dealing with combination pulleys. Okay, in simple machines, at first we studied about simple machines, terms related to simple machines. Then we learned about the first type of simple machine, that is lever. And in the case of lever, we studied about three types of lever, how to find its mechanical advantage, velocity ratio, and all those things we studied. And in the last class, we learned about pulleys, and we learned about the first type of pulley, that is a single pulley. And in case of single pulley, we have two types of single pulley, a single movable pulley and a single fixed pulley. And we learned about its similarities and differences between them. And today we will be dealing with the second type of single pulley, that is combination pulley. And the case of combination pulley, at first we will study about a combination between single fixed and single movable pulley. Here the combination is between single fixed and single movable pulley. So look here, the first pulley shown in the picture, it is fixed to a rigid support. The first pulley here is fixed to a rigid support, and the second pulley is free to move up and down. The second pulley is free to move up and down. And there is a thread which is fixed near to the movable pulley. The thread is fixed near to the movable pulley, and this thread is running through the first movable pulley, and then it passes through the fixed pulley, and we can apply effort at this end of the string. Okay, in your textbook, the string is called tackle. We can call it a rope, string, thread or something, and it should be inelastic and it should be massless if we want to make this machine an ideal one. Okay, why do we use such a system? We already learned that mechanical advantage of a movable pulley is 2. Mechanical advantage of a movable pulley is 2, and the mechanical advantage of fixed pulley is 1. So basically we learned a fixed pulley is used for changing the direction, and this movable pulley is used for increasing the mechanical advantage. By combining these two pulleys, we will get the advantage of having a higher mechanical advantage and also changing the direction. Okay, if you are using only a movable pulley, then the string will have to be pulled in the upward direction for the load to be lifted upwards. If we are using a fixed pulley, you can change the direction of application of effort in the downward direction. Okay, here effort is supported by one tension here represented by this upward arrow mark, and the load and the pulley together is supported by this arrow and this arrow, that is tension here and tension here. So if we are calculating the mechanical advantage of this pulley, Ma is equal to load by effort, which is equal to load, tension, tension. Two tensions are supporting the load. So 2 tension divided by the effort side is supported by just one single tension. So T. So we get the mechanical advantage to be 2. So when it comes to velocity ratio, the velocity ratio of this combination is 2d by d. That is from the formula effort arm by load arm, or distance moved by effort by distance moved by load. So if we are moving the effort from this point to this point, and the rope is stretched this much, the load will be moving upward the half the distance of the. If effort is moving a distance of 2d in the downward direction, load will be moving only a distance of d in the upward direction. So velocity ratio of this combination will be 2, and if we find the efficiency is equal to mechanical advantage by velocity ratio, which is equal to 2 by 2, which is equal to 100% if this system is ideal. This system cannot be ideal because there are some problems. One, we already discussed that friction. The first problem is friction between the axis of rotation and the pulley. In some cases, in some places, the pulley may be fixed and the rope should run around it, and there is friction between rope and this pulley. Okay, anyway, friction in the pulley. And the second problem is the string is not massless, so the mass of the string also is to be supported by this effort. And third case is, here along with the load we also have to balance the pulley. We also have to balance and lift up this pulley also. So we have to give an effort for lifting the pulley, and that also becomes a drawback, and in real case or in a practical machine we are not able to get 100% efficiency. But we still can have higher efficiency by making this movable pulley really small. So if the mass of the movable pulley is small, we can increase its efficiency. Okay, I hope this part is clear for you. Now we will go to the second type of combination pulley, that is a block and tackle system. Okay students, now we are continuing with the second type of combination pulley, that is a block and tackle system. I have drawn two pictures. Here you can see a block and tackle system. I will explain. Before I explain this, I will show you how a real block and tackle pulley looks like. So here you can see some pictures over here. The first picture you see here is that of a block which is containing 9 pulleys. You can see 9 drops coming in 3 sets. So 9 pulleys are rotating, and the next picture you can see 3 pulleys connected in a single axle. So all these pulleys are connected in single axis, but for diagrammatic representation we show all 3 pulleys separately, one beneath the other. So in real life they are all connected in a single rod and rotating simultaneously. Okay students, now coming back to a block and tackle system. The first set of pulley which is connected to the rigid support is called a block, and in our book the second set is also called a block. So 2 block and the rope running around it is called tackle. In some books they say the first set is called block and the second set is called tackle. So anyway, you make sure we call it a block and tackle system. So how to run the thread through a block and tackle system? This is the first type where number of pulleys in both the blocks are the same. So here 2 pulleys, and the bottom block also, the movable block also contains 2 pulley. So here the upper block contains 3 pulley and the movable block contains 2 pulleys. So these are the 2 types of combination which we have to study, that is number of pulleys in fixed and movable block is same, or number of pulleys in the movable block is 1 less than number of pulleys in the fixed block. Okay, now running the thread through it. So after drawing this wedge, when you run the thread, always start from effort, always start from the effort. This is how you draw effort. Effort E in this direction, and the thread coming through this pulley, we will continue this thread here to the last pulley here. So from the first top pulley we will draw it to the last pulley, and from there we will draw it to the second pulley in the first block. Okay, from there you draw it from this side to this pulley, and from this pulley there is no other pulley to go, so it will be connected to the upper block. So you can draw hooks and connect it, or you can simply connect it. If you are drawing a hook, then you can draw a hook. Okay, so make sure this block is not connected in any other way to this block. So if you are following the Ratnasagar book, I think the picture, in that picture they have shown 2 blocks connected to each other. That way a pulley system cannot move. This bottom part should be freely moving downwards. Okay, here we will be connecting the load. So load wants to go downwards, effort is pulled here, and pulling this effort downwards will create a tension here in the upward direction, and the load is pulling downwards, and which creates a tension in the string, and there are 4 strings supporting the whole movable pulley system. This is string number 1, string number 2, string number 3, and string number 4. These 4 strings develop tension. So this one single tension developed by effort in this part is supported by 4 tensions which are all supporting the load. So in that case, load can be represented as 4 tension and effort can be represented by a single tension. So when you calculate mechanical advantage will be 4T by T, that will be equal to 4, and in the case of velocity ratio, if the effort moves a distance of 4 distance, that is, if the effort moves this much distance, if you are pulling the rope to this much distance, the load will be moving only a distance of D. So if effort moves 4 distance, the load will be moving only a distance of D. Efficiency will be mechanical advantage by velocity ratio, which is equal to 100%. And this 100% efficiency can be attained only if we have a massless string, and the bottom pulley should be massless, and also there should not be any friction in this system. So it is sure that we will not attain 100% because we cannot make a frictionless object and we cannot use a massless object. So this pulley is there, string is there, and friction is there. That reduces the efficiency of this block and tackle system. But what is the benefit of this block and tackle system? Look at the mechanical advantage 4. Mechanical advantage 4 means it multiplies the force 4 times. Whatever effort we are applying here, they will multiply the force 4 times. They will multiply the force 4 times. And only drawback is that if we are pulling the effort a distance of 10 meters, load will move only a distance of 2.5 meters. That is 1/4 of the distance. If you are pulling it 4 meter, the load will be lifted only 1 meter. But the good point is that since the mechanical advantage is 4, if we want to lift a load of 100 kilogram, we just have to give an effort of 25 kilogram force. But that is in the case of ideal, but at least you can increase 5 more kilogram force. Maybe a 30 kilogram force can lift a load of 100 kilo. That's still good, right? So this is a block and tackle system. We see its use in cranes, ships, and for lifting heavy objects like cargo and moving it from one place to another. And here also another method for finding the mechanical advantage is that this effort is supported by one tension here, and load is supported by 4 tensions here. That means load is equal to N times effort. Load is equal to N times effort, and N stands for number of pulleys. N stands for number of pulleys. So if we want to find mechanical advantage, then mechanical advantage is equal to load by effort, which can be NE. The load we substituted by NE divided by effort is E. Okay, so we get the mechanical advantage as number of pulley. N stands for number of pulley. So if you are using 4 pulleys and the effort in the downward direction, then mechanical advantage will be equal to the number of pulleys, that is 4. Here we can look at the second figure here. Okay, here again we start from the effort part. I am drawing it here. Effort from the first pulley, and from here the string is going to the last pulley, and from this pulley the string is going to the second pulley here, and from this pulley it is going to the second pulley over here, and from the last pulley here it will be connected to this block. So I will show another picture on the side and it should look like that. I think the strings are very close to each other, but still you can see it, I think. So effort is applied over here in the downward direction. The load is pulling the whole system in the downward direction, and effort is supported by one tension, and the load and the movable block is supported by 1, 2, 3, 4 and 5 strings. So a number of tension will be T, 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 T and T, that is total 5 T's. So load is supported by 5 tension, effort is supported by 1 tension. So as we calculated earlier, mechanical advantage is equal to load by effort, which is equal to 5 tension divided by tension, and the value is 5 mechanical. That means you need to give only 1/5 of the mass of the load as the effort. So if the load is 100 kilogram force, then you need to apply only a force of 20 kilogram here in the effort side to lift this. But there are some problems like mass of this movable block and the mass of the string and the friction. To overcome that, you have to give some extra more than that. Then we have velocity ratio. Velocity ratio is equal to 5 distance divided by single 1 distance, which is equal to 5, and as you know, efficiency is equal to mechanical advantage by velocity ratio, which is equal to 5 by 5, which is equal to 100%. I hope you can see it over there, 100%. And for claiming it to be of 100%, we make some adjustments. We consider that the string is massless, the whole system is frictionless, and the lower movable block is also massless. Okay, then if you want to increase the efficiency from maybe 70% or 60%, if we get efficiency, if you want to increase the efficiency, these are the 3 things you have to improve on. Make the lower pulley or lower movable pulley or lower movable block as light as possible. Then use a thread which is inelastic, inextensible and as massless as possible. Its mass should be very less. And the third thing, make the whole system as frictionless as possible by lubricating it. So these are the methods for increasing the efficiency. So I think we reached the end of explaining a block and tackle system. So first system had 2 by 2 pulleys, 2 in the first block, 2 in the second block, and the second system has 3 in the first block and 2 in the second block, a total combination of 5 pulleys. And like here, you know that load can be equal to N into E. The same thing also is applicable over here, and we can calculate the efficiency in that method also. Okay, now we will do a problem. Okay students, here is an example question for you. A block and tackle system has 5 pulleys. If an effort of 1000 Newton is required to lift a load of 4500 Newton, calculate its mechanical advantage, velocity ratio and efficiency. So how can we calculate mechanical advantage? For calculating mechanical advantage, we need to know load and effort. What is the load here? A block and tackle system has 5 pulleys. So we will write the first thing we know, N is equal to 5 pulleys. If an effort of 1000, so we write E is equal to 1000 Newton is required to lift a load of 4500. So load is equal to 4500 Newton. Calculate its mechanical advantage. So what is mechanical advantage? mechanical advantage is equal to load by effort, which is equal to 4500 Newton divided by 1000 Newton, and what we get is 2 zeros are cancelled and Newton also will get cancelled, and we get it as 4.5 is the mechanical advantage. 4.5 is the mechanical advantage. Then how will we calculate the velocity ratio? So calculating velocity ratio, we use the method we used earlier, that is simply you can write velocity ratio is equal to number of pulley n, which is equal to 5. So next, finally we have to calculate its efficiency. I don't have enough space to write here, so I'll write over here. Efficiency is equal to mechanical advantage divided by velocity ratio, which is equal to 4.5 divided by 5. What is 4.5 divided by 5? 45 by 5 is 9, so it will be 0.9. So 0.9, when you multiply it by 100, you will get the answer in percentage. 0.9 into 100 is equal to 90%. So this block and system over here, which can lift a load of 4500 by an effort of 1000, has a mechanical advantage of 4.5, velocity ratio of 5, and efficiency of 90%. Now we will do another question. Okay students, the second question reads like this. A block and tackle system has velocity ratio of 5. Draw a label diagram of a system indicating the direction of its load and effort. And B, Anwar exerts a pull of 150 kg force. What is the maximum load he can raise with this pulley system if its efficiency is 75%? Okay students, here we see that the velocity ratio of the pulley system or block and tackle system is 5. N is equal to 5. That means there should be 5 pulleys. Then how can we draw 5 pulleys? We can draw a block with 3 pulleys in the fixed position and another block of 2 pulleys in the movable position. So here, like shown in this picture, you have to draw. Okay, for the B part, the question reads, Anwar exerts a pull of 150 kg force. What is the maximum load he can raise with this pulley system if the efficiency is 75%? We will write down the things that we know. The effort applied by Anwar is equal to 150 kg force. And the efficiency of the system is 75%. And we are asked to calculate how much load he can lift. So how can we find load from this question? So for finding the load, we need mechanical advantage. So from the formula of mechanical advantage, we can divide load and effort, and if there is mechanical advantage, we can easily find the load here. We don't have mechanical advantage, but we know N is equal to 5, that is also equal to velocity ratio, and we know efficiency of this machine. So we can now calculate mechanical advantage using these details. The formula, efficiency is equal to mechanical advantage by velocity ratio, that is equal to mechanical advantage we don't know, but efficiency is given 75%. Efficiency is 75%. Mechanical advantage is not known to us, but velocity ratio is known, which is 5. Okay, so we get, I am rearranging the position. So mechanical advantage is equal to 5 will go as a multiplication on this side, and 75% I am writing it as 75 by 100 into 5 will go here, so 5. So I am going to leave mechanical advantage there like that. Then we will continue with finding the load. So how can we find load? Mechanical advantage is equal to load by effort. Mechanical advantage is equal to load by effort. And here we know mechanical advantage as something like this given over here. We will write it as a whole. Without dividing, I am going to write it over here. 75 by 100 into 5 is mechanical advantage, which is equal to load we are going to calculate divided by effort. How much is the effort E? 150 kilogram force. We are going to write that 150 kilogram force. So for finding load, this 150 should go here. So I am rearranging and writing it as load is equal to 150 here. So 150 into 75 into 5. The whole divided by 100. We can cancel this 0 and this 0. 5 will go 3 times. In 10, 5 will go 2 times. Then I am going to cut this 2 and 5 and I am writing 2.5. 2.5 into 3 into 75. 2.5 into 3, 7.5. So that will be a better number. 7.5 into 75. So when I multiply them both, and I missed the kgf here, remember kgf is up here, it is there. So 75 into 75 and we can change the decimal place. So 75, 5 5s are 25, 5 7s are 35, 36, 37, 0, 7 5s are 35, 7 7s are 49 plus 3, 50, 51, 52. When you add them, it is 5, 12, 6, 5. So the decimal place of 7.5, when you add that here, your final answer will be 562.5 kilogram force. So this is how you calculate the answer for the second part. We got the load to be 562.5 kilogram force. This much load can be lifted by an effort of 150 kilogram force if its mechanical advantage is as such given here. I did not find the value of mechanical advantage for the easiness of calculation. If in the question it is asked to find the mechanical advantage, you have to solve this and find the mechanical advantage before going there. But since they asked only that load to us, we found the answer only of load. Okay students, I hope this problem is clear to you. If it is not clear, please go through this video once more and make sure you understood every point. And I will give more questions in classroom. You can find your assignment over there. Go and check it, do it, and if you have any doubts, you can call and ask. Thank you all.